we're at the center. They had
you're roboting real
but
bad,
they just said, "Oh, we're just going to say everybody's experiencing it." The principle.
He kind of rugged out there. I don't know. Did anybody? Was it just me?
I think she made a point about the principle in general geocentrism, but I didn't hear the specific. But I agree. I can tell you I agree.
Yeah, whenever we saw space expanding, it looked like we were in the center, but they couldn't accept that. They had no evidence to reject it, though. But they just said, "Oh, everybody experiences it."
Nailed it. Right. Yeah, she was making fun of the Copernican principle, how they reject evidence of us being in the center based on the philosophy and not the science, I think. Which also is, I agree with.
I think we are in the center. That's the difference. We are in the center of our observable universe.
That's not the difference. That's what the mainstream model says by way of observation and inflating and expanding outward universe, right? That's the claim.
Hold on. He thinks that no. He said he thinks we're in the center of the universe. Like, so you believe in geocentrism? Is that what you're saying?
I believe we're in the center of our observable universe. Yeah.
So yeah, I mean, which is like billions of light years across, according to the mainstream model. So you think that we're in the center of all that?
Yeah, basically, yeah.
So why would Earth be in the center of everything?
It's not in the center of everything. It's in the center of our observable universe.
The known universe, as far as we can tell, the edge of existence is the known universe.
So he's saying everybody's in the center of their own observer point. That's what he's saying.
Exactly.
Well, he's trying to poorly articulate the mainstream position, Piezo, which is that it only appears that way, and it would appear that way for everyone, so as to justify the heliocentric position, and so that it'll always look geocentric. That's the actual truth, right? That's what they did.
Yeah, they don't claim that we're in the center of the observable universe. So they say it just appears that way. Yep. Like kinematically, it appears that we can see everything with respect to us as moving around us, but it's not actually true. That we're just like a speck in a sandbox, tucked away in some insignificant corner somewhere at random.
See, I don't think we're insignificant. I think we're special. I think our blue ball is incredibly fucking rare in the universe, and I don't think there's another one like it or us.
Yeah, well, you're not wrong on that part.
I mean, technically it's not, but...
It's the one part you should agree with me on, Brian.
Yeah.
But, we also are not moving. That's the thing, Shannon. Like, we don't move. Earth is absolutely, stationary. Aside from earthquakes, etc.
Look, honestly, I don't think the Earth is rotating. Sorry, I don't think the Earth is stationary, guys. Like either the stars are fucking turning, or the Earth's turning, or they're both turning, which is more fucking likely, and I think is what the reason why the Markson and Morley experiment actually fucking failed, because they didn't consider that maybe the universe is actually turning as well, and it could be turning in the fucking opposite direction to our heliocentric fucking way. I don't know. I doubt any other fucking astrophysicist would know. It would probably just be a theory like fucking anything else, I
don't know, man. This is just speculation, but I think they actually were under the impression that the Earth wasn't in motion, due to a previous experiment from, George Bedell Airy with a telescope and filling it up with water.
Look, you know what? Look, I think at the end of the day, it doesn't matter whether it's the Earth spinning or whether that's the universe or the stars spinning, whatever. Like, it's something we can see. It might be the Earth spinning, it might just be space spinning, or maybe it is both spinning, which I think is more likely. Yeah, because if the whole space is spinning around us, why wouldn't everything else be spinning? Yeah. And then I think the universe is spinning as well, probably at 5 trillion fucking kilometers an hour.
So you are a geocentrist, then?
Why would you think
that? Why would I think that? That's a good question, Taylor. Because that's what I think.
Why?
That's a great point.
Oh, it's just sort of based on stuff that I've learnt watching documentaries and listening to people talk and stuff like that. And it's just their theory. It's just my theory, you know. It's like anything else. Don't ask me for how did I have the scientific method or blah blah blah. It's just a theory.
The hell with evidence or
So
whatever. It's just what I feel.
if somebody tried to like convince you like that the sky is like red or something, I don't know. Like that you drive a Lamborghini, like would you say, yeah, definitely. Somebody told me that. But like that's not what I've experienced. That's not what I've seen. That's not what I observe. Like you're not gonna like at what point do you put your foot down and say like, hey, you're not gonna tell me like what I've seen and experienced.
As I said before, science is always evolving, and there's some people that can think outside the box, and there's other people that are stuck inside the box. If you get what I mean.
Well, don't
Well,
you
we're
think
all
that
cool with
we're
science
thinking outside the
evolving.
box? You know, being told that you're spinning through space is like the box that you're being taught through the box on
Well,
your television since you're young. Like, have you thought about that?
I disagree with that, Taylor.
So
No,
you haven't been told you're spinning through space since you're young. Yes, good.
and again, you say science is evolving. If you have an experiment and the way they had to get the answer they wanted, they had to bring in a mathematical equation and shrink the apparatus. Do you think that's science evolving or science cheating?
Well, I don't know the full circumstances behind what you're describing, Brian. So, but
What
but on
happened? It
but
did
on
happen.
but on the face of what you're saying, it would sound a little bit like fucking cheating, yeah. But like as I said, I don't know exactly what you're talking about, but on the face of what you said, I agree. Yeah.
Nice, because what he's talking about, I'm going to give you a quote from Arthur Eddington, right? Who later they use his work to confirm relativity, right? But he says Michelson-Morley experiment has failed to detect our motion through the ether because the effect looked for, the delay of one of the light waves, is exactly compensated by an automatic contraction of the matter forming the apparatus. So literally he's saying, listen, you'll never detect it, but alas, it's because that the device you're using will contract imperceptibly in the direction of motion, making that motion imperceptible to your instrument. So that's the thing that you'd have to believe to maintain the belief that Earth is moving around the sun in the absence of any such measurement. I think that was the point.
Look, there's some things that are hard to measure, guys. It's just, and they're hard to, you know, like even
This one
Taylor
is
will.
super hard, bro. You're right. Super hard.
Yo,
So no human's
Shannon,
ever done it.
real quick though, like I know this is like a discussion in a room in front of a bunch of people, but like if nobody else was here and it was just me and you, I'm gonna try to talk to you like I would, like as a real person, man. So like, just imagine you're like, we're gonna be the first people to actually substantiate, Earth motion by using a tool machine to measure it, right? You're like, we've tested our machine out. We know that our machine is at least 6 times more sensitive, or sorry, 30 times more sensitive than it needs to be to measure this motion. Like, Earth's moving really fast. It's like 66,000 miles an hour. So we've got 30x that sensitivity on our machine. So we know we can measure it. They go to measure it, and they don't measure the motion. They don't measure anything moving, right? And they say, you know what? We're so absolutely certain that we are moving because we just already know, right? That we're going to assume that instead of our machine giving a correct reading, that's, actually a reading of us not moving, we're going to assume extra hard we really are moving, and that time, the very fabric of time and space itself, caused our device to shrink by the exact amount it would need to turn the measurement we expect it to measure into a zero. That's literally what happened. That is history. I just repeated history to you, bro. Like, does that not if I was sitting here and I was the scientist, like this had just happened, like we just performed this experiment, it's like 1887 right now, and I'm talking to you and explaining to you what would just occurred. If I tried to present that explanation to you, would you not look at me like I'm a retard? Be honest, dude.
Like I said, there's some things I can't really comment on, but like I'm a logical dude, and if something makes sense, I will agree with it. And as I said before, I agree with something that Brian said earlier. You know what I mean? So if it makes sense and it's logical, I will agree. You know what I mean? But
No, hold
yeah,
on a second. Wait. I hear you laughing, dog. Like I know it's funny. It is funny.
It
I'm
does
laughing
sound
too.
silly.
Like, but you like are holding back your laughter because you know it's retarded. Like these people are telling us that the machine shrank by the exact amount to make the reading turn into a zero. We just can't tell.
You can't accept that in good faith and to try to defend that to us now. Like no man would do that, right?
Dude, we are
We
literally
understand.
on
We
this guy's
understand
theory right now
that.
too. We're actually
huh?
on special relativity right now. The whole system we're in is Einstein's special relativity, general relativity stuff.
So like by the standards that you put forth while being a logical guy and following what you know, then so far all you can say is that you live on a geocentric maybe globe that doesn't move because everything we've been talked about so far, right? So I
Look,
mean, is that your position?
nah, not really.
No,
No, I don't think.
you still think you move in the absence of any such measurement throughout all of human history, and you accept the fact that you'll never be able to attain such measurement because the device you use, again, will contract in the direction of the motion you're trying to measure in the exact amount that would be imperceptible. You accept those parameters then, right?
So, all right. So you're talking about the interferometer contracting, yeah? So how did it contract? Explain that to me.
It didn't. There's no physical justification for it ever doing so. There's no evidence that substantiates it. It's literally just a math equation.
Yep.
All right. So what was the point you're trying to make, man? I sort of got a little bit
Well,
lost. Are you
the reason
saying
that
that?
it exists, the reason that it was invoked to explain a measurement was that when they went to measure the already quote known motion of the Earth around the sun using a device specifically built for it, in an interferometer, which is just a laser or a light beam, which gets routed around and then recombined in a pattern, the
What laser?
interference pattern.
What laser
I'm
did they have
just
in 1880? What
it's
laser did they have in 1880?
the
Which
It was a light.
The Michelson Morley interferometer was like the
It,
most sophisticated one that they built for the time,
they
suspended in
had fucking a
mercury.
laser in
it wasn't a
1880?
hold on. It
It
wasn't a
wasn't a
laser.
laser. It was
It
It
wasn't a
had
laser.
light.
It was a sodium lamp. But sodium they used the sodium lamp because sodium lamps emit coherent light, which is all in phase the same way the laser is. So it's not a laser beam, but it's the same type of light that a laser emits.
yeah, the modern
I,
ones
don't- I,
are laser beams. The interferometers that they use later.
I don't even think they had sodium lamps back then in 1880.
Oh,
Well,
they had them, man.
they built the most sensitive instrument that they possibly could, specifically to detect this motion, with the presupposition that they knew that they were moving, so they were obviously going to detect it. Which is why, when they failed to detect any such motion, Einstein had to come along and say, "Well, actually, it's because the device you're using to measure it contracted in the direction of the motion that you're trying to detect, and you'll never be able to detect it," which was a Lorentz contraction, which they employed and stole from Lorentz, which then gets applied to general relativity, which also redefines all of physics. So now the motion they're trying to detect isn't a circular motion around the sun. It's a linear geodesic being pulled by the curvature of space-time. That's what Einstein added, right?
So, and I just to clarify, the sodium lamp was used to produce monochromatic light, which means light of one color. And
You're
they
kind of
used that.
rugging out, Piezo.
Can you hear me now?
You're real low.
I said, is this better?
A little bit.
They used the sodium lamp in order to produce what's called monochromatic light. It's like one color, right? So they would only be one color because actually light of different colors travels within like one group at slightly different phase velocities. So they used monochromatic yellow light in order to tune the machine, and then they went back to white light for actually doing the real measurements using an argon lamp.
And some of the key points here are they were looking for 30 kilometers per second to equate to 66,000 miles around the sun. And they didn't get that, but they got 4 to 8 kilometers per second, which means they still had motion, just wasn't us going around the sun. And then they came in with the Lorentz transformation and shrunk that motion away.
Look, honestly, I don't know why you guys get so hung up on like this one little point. It's like, for me, it's not really conclusive.
Machine, bro.
First, yeah.
They said the machine shrunk with a mathematical equation.
It's not a little point, man. It's like the most famous experiment ever. It's the most represented experimental result ever. It's literally the cause and the catalyst for the redefinition of all the physics. Einstein cites it specifically for its creation of general relativity. Like it's a huge, and then it's very, very important. That's why we talk about it.
It's huge, dude. We're literally living in Einstein's special relativity world right now. We got theoretical physics. We got experimental physics. I mean, you got string theory out there. Now I mean, seriously, all because they shrunk a machine, dude. You really think you can shrink a machine?
Well,
without noticing it?
I don't know what to say to you guys about this. Sorry.
Well, here I put a video in the nest for here about all the motions that can never be detected. It's a pretty good representation of all the relative velocities of Earth. It's got Earth rotation, Earth orbiting the sun around orbiting the Milky Way relative to the microwave background. All those motions are simultaneous and huge. And just remember, none of them are detectable ever. No one has ever measured any of them, but we super know that they're happening at all times everywhere.
This is the problem. Like, you're measuring the Earth's rotation and Earth's orbit and the sun's velocity and all of this. You're using miles an hour. You're using an Earth-based calculation to do that, which is like, it's wrong. You should be using astronomical units and referring to how many rotations it does in a day, like RPM, yeah? Because like that's how we measure rotation. We don't do it by that. We do it by degrees, or we do it by So
15 degrees per hour. Yeah. So just so you know, like, I'm not misrepresenting the historical context of this experiment when I tell you that they were attempting to measure the relative motion between the Earth and the ether, assuming that the Earth is flying around the sun at 30 kilometers a second, so they predicted that they would be able to measure that based on the fact that if you think about light, it's like a projectile, like a bullet, right? Like a photon is like a bullet. So like if I was to be, shooting a bullet out of a gun and a deer was to be standing still, if the deer runs away from the bullet will take a little bit longer to get there. If the deer runs towards the bullet, then the bullet will take a little less time to get there. Same thing with light. They shoot this light at the mirrors, and if the entire device, like it's mounted to the Earth, right? If the Earth's flying through space, then after that light projectile gets launched, the mirror will either be flying towards the light or away from the light in one direction. And so based on that should create a travel time difference along one half of the machine compared to the other half. So that's what they were measuring. They were just like, yeah, Earth's moving super fast. The light's going to be, shooting its own speed, and Earth's going to move towards the light or away from the light. And that difference is what we're going to measure. You would have to measure it. It's a requirement. And so when I tell you that was what they were measuring, and they claim that the reason they didn't measure it is because the arms of the device shrank by the exact amount necessary to offset the expected difference, I just don't see how any person could ever believe
that. See, that sounds like bullshit to me, bro. I agree with you.
Nice.
I agree with you on that point. You know what I mean? Like,
It's called length contraction.
it's
It's
like
called length
bullshit.
contraction.
Well, we're living in it because of that experiment and that equation. They changed all of physics, man.
Yeah, so that was the basis, just like continuing the history lesson, Shannon. That one experiment was the entire basis for switching physics as we know it from what you would call classical physics, which is where everything in the universe is mechanical and operates by the principle of local action, to change physics from classical to Einsteinian or relativity. So Einstein built his whole theory based around this result from the Michelson-Morley experiment. They said that the speed of light is something that can't be changed. It's super duper constant. And if you're an object moving towards it or an object moving away from it, it doesn't change the amount of time it takes for the light to get to you, because you will either warp time itself or your length will change in order to make up the difference so that it still takes the same amount of time.
Ooh,
Great.
real quick, Pedro, did you see Stone did a graph of this? Actually, he graphed dilation versus time, like contraction, and it was hilarious using the actual. If you think about it from the perspective of the observer, he's already dilating in the direction of motion perpetually, so he appears to slow down as he speeds up to infinity. It's really hilarious. Anyway, continue.
Yeah, so that's the thing that changed physics, bro. Like that's literally what Einstein. The reason you know Einstein's name is because of that. That, like, yep, length contraction, guys. And the only reason, Shannon, literally the only one, the only reason that they proposed that explanation is because the alternative would have been to acknowledge that the machine actually just gave a reading, and the reading was zero, or technically it wasn't zero, but it wasn't what it was supposed to be. It wasn't 66,000 miles an hour. So, because they were unwilling to discard their previous notion about us flying through space at mind-numbing speeds, they said that the very fabric of reality itself will actually shift and bend and warp and stretch in order to make sure that our device reads zero. I mean, like, I can't think of a more fundamentally retarded and incoherent position in all of science in the history of humankind than that.
Look. All I can say is what I was saying earlier, that science evolves. Yeah. So
Come
democracy.
on, I thought you were denouncing it, not defending it, man. You letting me down.
How is that evolving science, though? If you
Listen, didn't let me finish.
if you have to use an
You
equation to
didn't let
shrink the
me
apparatus, how is
finish.
that evolving science?
You didn't let me finish. All right. Now you interrupted me and you interrupt my train of thought, and I forgot what I was actually going to say back to you. Yeah. So please don't interrupt me when I'm talking back to you. Yeah. Makes it difficult.
Man, maybe that's my bad because you keep on going into your science is evolving speech, and like I said, man, if you have to shrink the apparatus, that's not science.
I remember. You prompted me. All right. So the Michelson-Morley experiment was about 1880. I think you guys said. Right. That's
1887.
Dude, it was
yeah.
1887, and here's the kicker, man. They still use the interferometer today.
Yeah. I get that. But how many years later was it when Einstein postulated his theory of
18
relativity?
years.
18
How
years, man.
18 years later was it?
Yeah,
Yeah. So it was
Physics was
18 years.
basically in
1887.
turmoil for 18 years
One
because
Dude,
we
second.
couldn't figure out.
1887 to 1905, right?
Yeah.
All right. So 1905, Einstein come up with his theory of for theory of relativity, all right? And then in 1950, I think it was, some scientists confirmed the theory by recreating the experiment and measuring gravitational lensing of light, all right? Now, that's the response I have to that. I don't know what else.
So here, I will also say this, Shannon. If you go to Google or AI and you ask it for like the confirmation of this, I can almost guarantee you that every single case example that it's going to feed you as like proof of these theories, we've already looked into and probably even have presentations regarding them, because we actually took the time to deep dive into the original papers of when these experiments were performed to demonstrate like what's a fact, what's not, what's presumption, what's not. And it's actually odd, bro. Like, here's the thing: are you a religious person, Shannon?
Well, not religious like you guys, but I believe in the creator. Look, let me. So with the just let me finish. Before with the gravitational lensing, you guys can actually observe that yourself when you take a picture of the moon and you can see the stars where the moon should be. That's the gravitational lensing in effect, I think.
Okay, that's it. Okay, that's not correct. But let me just continue. The reason I asked you if you're religious is not because I'm like interested in
Your mic's kind of low again, Piezo.
the reason I'm asking you if you're
Right.
religious is not because I'm at this moment trying to question you about God. It's because the premise or the principle that in like religious belief systems, you have an element of faith in what you're taught, right?
Okay. All right. So for me,
Hold on, man. Let me finish. We're letting you finish. Let's take turns. So, and based on that element of faith, like that's usually like the backbone, the foundation of pretty much every religious belief system, right? Like at some point you have to build a faith. But science is meant to be the opposite of that, right? Science is supposed to be, just cold, hard, objective knowledge based on facts and the ability to test those facts. So, like science is not supposed to require any faith. It's the opposite of faith. It's supposed to be. And so when you actually dig and you look into many of these experiments, right, you find that there's always a human element involved that seems to be affecting what gets told to the public. For example, the lens stirring effect or gravitational lensing, if you go back to when it was supposedly first proven, quote unquote, what was it? It was like 1932 or something. I don't remember the year, but they had photographic plates that they were taking these images of the sun on. Okay, and when they took these measurements, they were supposed to be able to measure like within like the arc second range or sub arc second range the deflection of light around the body of the sun of stars of known positions. They took 32, if I'm not mistaken, photographic plate images, and out of those 32 that they took, guess how many they have today that they claim, or I don't think they still have them today, but guess how many they pulled away and used as proof of this effect that they claimed relativity predicted? 4. 4 out of 32. Now that would lead a person to question, well, what about the other 28? Did the results of the other 28 not seem to agree? Because if they did agree, then certainly they would have included those in the number of proof plates, right? Well, of course they would have. But
I'm guessing. It's just a guess. It's just a guess, Paizo, that they didn't have like sort of modern photography of like what we have today, and they only had a certain number of plates to catch a certain arc second range. You get what I'm talking about, and like so there was maybe only 4 plates that actually only captured what they needed to capture, and the other 28 plates weren't within the arc range.
yeah, so if 28 out of 32 disagree with your prediction and 4 out of 32 do, would you consider your prediction accurate? I wouldn't. So, and that experiment's never been repeated, by the way. They did it one time 100 years ago, and they're like, yeah, boys, that's all we need. Never need to test this again. Trust us, it definitely is real. And that's actually the case with a lot of different things.
Look, I'm only guessing, Paizo, but like the experiments using the photosensitive plates was like older technology, and I know Brian's going to hate me for saying this, but science evolves, and they come up with a different method to measure this stuff. Using lasers and stuff like that. I don't know.
Would you be willing to acknowledge that you're just like kind of making this up as you go based on what you're assuming must be true in order for the model to be correct?
Alan, you suck.
Alan, you suck. You're ruining the conversation.
Hey,
Yeah. Echo.
Yeah, someone telling you immediately ruined everything. Okay, we're good.
Yeah, I was going to say, Shannon, would you not agree that you just made that up based on something you actually don't really have a lot of background knowledge? You're just making some assumptions in order to be able to still maintain the fact or the idea that your model's correct. Like, well, if my model's correct, then that must have meant that they only got the results of 4 out of 32 because the technology wasn't good.
Anything I say is based on fact. What are you talking about?
Well, so then you accept the only evidence showing the thing that you claim came from 1919 using a Jesuit Voyage telescope 4 years after
You,
it was predicted. Hold on. But the 13-inch telescopes all failed, but this one definitely did it, and the team used it to confirm the deflection, but it never been repeated during any similar solar eclipse since, right? Is that what you believe then?
I believe that science has evolved and they can measure it with more accurate equipment today.
Well, why don't they do it then? It's not been repeated. Isn't repeatability one of the fundamental tenets of the scientific process?
You know, I heard they don't use anything with the sun anymore. Are we talking about the sun right now or the moon?
Gravitational lensing. It's the sun.
What?
Gravitational lensing. We're talking about the sun.
No, we're not talking about the sun. We're talking about the effect of massive objects to curve light.
Right, which they use the sun to purportedly prove. Because our sun is the only object in our solar system with enough mass in order to produce a measurable effect. Yeah,
Dude,
oh, sorry. Go ahead, Stone.
sorry, Pizzo. Just to mention to Shannon, when we talk about gravitational lensing, exactly like you're talking about how the only place we've ever been able to measure that, allegedly even, is bending light around our own sun. And the man in question, his name is Eddington, and he asserted that it was a thing. And later on, he confessed that he botched the
Like I said, like there was 28 plates, 28 of them were inconclusive, 4 were only good, yeah, that displayed their imaging that they needed, yeah, which I get. It makes sense to me. If you guys don't get it, that's fair enough, but I get it because, like, if I was to capture a something on a high-speed camera, right, say a bullet firing through the air, and I wanted to capture that bullet firing through the air, there might be 10,000 pictures, yeah, but there will only be 500 that actually have the bullet in it. Get what I mean?
Yeah, that's not how that works. That's not even totally
What do you mean? That's exactly how.
Experiment. It's not how
That's the
Star Trek experiment works. It's not like you're, taking a bunch of pictures and hoping that some of the ones in the middle will capture the bullet in the image. Like, that's not at all analogous to what they were demonstrating. They had the telescope lined up in the spot it needed to be in to look at the edge of the sun, right? The edge of the solar disk, because that's where you would see the effect. And then they were just watching and developing plates as the stars passed the disk of the sun. And
I understand that, but like this is a sort of little bit of difference between me and some of you guys. I can acknowledge something that you guys say, but rarely will you guys acknowledge something I say. And like when I bring the comparison between a high-speed camera and the way they captured that gravitational lensing only on the 4 discs, which I say they had a total of 28, that might have been the 4 in the middle. It mightn't have been the 4 at the beginning or the 4 at the end. It could have been the 4.
Brother, I'm trying to explain to you that that's not analogous to his experiment. It didn't work.
Yeah, you got a hot mic, Fawn.
It didn't work as if there's like a bullet flying by and we've got to snap a bunch of pictures and hope that somewhere on all the pictures we snap we capture the bullet. That's not it. It's we're looking in the same spot. We're going to develop all these plates and review them. And these plates are all developed over, X amount of time during the day as these stars are going past the sun. And we would expect that all the plates should show the same effect. We're measuring fractions of an arc second. And, oh, what do you know? 28 out of 32 don't show it and 4 do. We're talking about 4 plates demonstrating fractions of an arc second and 28 of them not. I mean, we're dealing with numbers that are already so small, it's kind of like absurd anyway. And besides that, only a fraction of them they claim actually demonstrated it. And you can't even go review the plates today, if I'm not mistaken. Back check me on that. Am I right on that, Shane? Didn't we try to look up to see if the plates exist and they don't still exist anymore?
Look, if you guys can't accept my response for why there's only 4 plates capturing the imaging out of the 24, I don't know what else to say. I'm not going to argue about it, but that's what I think, yeah. And you aren't going to change my mind on it because it makes sense to me.
So, like, have you studied this effect before today, before discussing it with us live right now, or did you look it up and that's what you found the search engines told you, and you're just making this up as you go?
Well, this is, look, I've been in the science for a long time before I started flat Earth spaces. Yeah.
I didn't ask you about your science background. I asked you if you knew about this experiment and the details behind it before this conversation, or if you just looked it up.
Well, what I was saying to you, I've known about gravitational lensing for a long time. Yeah.
So, did you know about the methodology of the photographic plates before I mentioned it? Because those words hadn't come up until I brought it to the conversation.
Yeah, I understood the basic concepts of it, exactly what we both described, the bending and curvature of the light around massive objects using the sodium plates to capture the imaging, and the only 4 plates capturing. I get all that, yeah,
So
I understand.
Then why would you be comparing it to a high-speed camera watching a bullet fly by its lens?
Because
it's not analogous in the least.
It's capturing one moment in time. That's what it's doing. It's capturing one moment in time. If you can't get that, I don't know what to say to you.
So why would 4 moments in time have gravitational lensing and 28 moments in time not have it when the mass of the sun doesn't change? It's always there.
It's the relation. I'm guessing it's the relationship of where the Earth was in relationship to where the massive objects was, and in relation to the picture of what they were trying to observe, the star, and then the gravitational bending around the massive object. There's lots of different things.
I'll leave you alone on this topic. You already acknowledged just now. You just acknowledged that you're guessing, which is what I was pointing out. That was my point from the beginning, that you're just guessing. You're making this up as we go. But please don't argue as if you know, if you are going to then just be guessing and you don't actually know.
What do you mean? What have I guessed about? Tell me one thing I guessed about.
You're the one that told me you were guessing on a recorded space. Everyone heard it.
I don't guess about. Listen, when I guess, I tell you I'm guessing. I say I'm guessing. This is a guess. I admit it. But if I'm not saying I'm admitting it's a guess, then it's not a guess. Then it's something I think is real and is based on a fact or science.
Yeah, so when I just asked you why would only 4 moments gravitational lensing be happening and 28 moments it's not, when the mass of the sun is
You're breaking up, Isaiah.
When I asked you why would gravitational lensing only quote unquote appear 4 moments out of 32 and 28 moments out of 32, it would not appear when the mass of the sun is there in space the entire time. It doesn't change. It's always there. If it's produced by mass, it must always be present where mass is present. The mass of the sun doesn't disappear, so why did it only appear in 4 of the plates? You said, I'm guessing it was...
It's not hard to work out. It's not hard to work out, all right? You're pretty smart, all right? Where was the pictures taken from? They were taken from the Earth. The Earth is moving around, around the sun. Of course, there is going to be a time where it's going to be the perfect time to capture the gravitational lensing, and there's going to be a time where you will not capture it. What are you laughing at, Ben? You come up and laugh every time I come up here to speak, but you know nothing to fucking say.
So hold on a second. He addressed me. Let me take a stab at this. You're talking about a bullet flying through a city street and being captured on a traffic light. How does that compare to a galaxy, which is not traveling at a speed of a bullet upon our observation.
I didn't talk. I didn't say it. I said a high-speed camera.
And that's why I laugh at you.
A second.
You
Like
can
in a
have
red
as
light.
many seconds as you
I think we
want.
should move on to the next topic. This one's actually like we're being point. It's been demonstrated. He acknowledged that he was guessing with the response. Like I don't want to keep talking about this thing anymore. It's actually tiring. I think we should change topics to something else.
Oh well, I'll drop down then. Fuck, fine.
I mean, you can still talk about science. I'm just saying not.
Well, I have another point about your analogy too. You're talking about a traffic cam that might pick up maybe 30 to 50 feet from the camera, and then gravitational lensing has to do with far off galaxies. So you don't feel like that's an apples to oranges situation?
Oh man, did you guys chase off Shannon?
Sorry.
I was
Dude,
busy.
you got so triggered just because I did an emoji. Like, I'm sorry if somebody's that fragile.
Yeah. I mean, dude, how many people are in the space? Some more. Like, I don't like it when people become combative, but it's like it always happens, like almost without fail. I feel like in 2 years of being on this platform and Friday Night Faces, there's been like less than the people I can count on one hand that have come up and discussed these things from the mainstream position and not gotten triggered.
Man, your mic is sucking tonight, man.
Is it lag or is it the mic breaking up? What's it?
Well, when you say that, what you just said came in nice and clear, but mostly it's kind of laggy and real low.
Maybe my internet's just being terrible for some reason.
When every time I point it out and you go, "Oh yeah," and then it comes in real clear, I'm like, "Well, now it sounds good." Then it goes back to shit.
Oh, dude, maybe they're having to adjust the bandwidth on their like recording on my internet backend, my personal agents, you know. JK. I don't know. Call my ISP, man.
But yeah, I mean, he kept on saying things evolve, science evolves, but it seems like it's devolving. I mean, can't shrink an interferometer.
Oh man, and dude, it's wild. Like, my position in science is that of pretty much all scientists for all of human history until Einstein's generation, which is scientific realism and the principle of local action. I think that actions only occur mechanically. Like I can't impose a force on you at a distance without touching you somehow or touching something that touches you. There's like a chain of things touching each other. That's how that's even how Maxwell, when he developed his theory of electromagnetism, figured everything out. He used fluid dynamics, which were classical mechanics equations. And then they took all the mathematics from classical wave mechanics and they removed the physical explanation for them and said these are abstract effects in fields of math. But the math is correct, but the physical basis for them isn't real. And here we are with science today. Removing the ether because even though it didn't solve to explain anything when it came to interferometers, that was the best thing that they could come up with was trying to explain why their machine didn't read the velocity of our Earth that it was supposed to. So now light is a wave in nothing. It's the numbers of space. There's just numbers, like the things that only exist in human minds, things that aren't actually physically real numbers, The numbers floating around in your head are changing through space, and that's making you see light. It's just so retarded, bro. But I wish there was some more mainstream people in here to talk to, because it's what makes these spaces not worth it.
Like when you combine it all together, they can't even explain their model. It's like when you actually include like the bending of space-time and all this crap, like how do you even illustrate that model? Like they don't know. And what's always funny is they don't even believe in the first premise of their model, which is the Big Bang. We only had a couple people really defending the Big Bang, but most of these people will even admit, like, yeah, it doesn't make sense. So it's like, what's their model even like founded on?
Well, they claim Michelson-Morley and atomic clocks are like the best proofs, quote unquote, of relativity. They say that Michelson-Morley is the proof of that length contraction is real, and that atomic clocks are the proof that time dilation is real. Because you can't actually directly measure length contraction. You can't actually directly measure time dilation, right? You can't, like, how are you going to do that? How are you going to measure, your object shrinking when the ruler you use to measure its length also shrinks along with it? Even your ruler shrinks. You can't, it's something you can't do. It's an unfalsifiable position. So what they do is they're like, well, we're going to just take something that we assume we already know, that the Earth's moving and we know how fast it's moving. So since we super duper extra double know that that's real, then when we try to measure it and it doesn't measure, then we just say, oh, the fabric of reality and length itself is changing. That's where we're at. And then atomic clocks, of course, are mechanical objects, just like anything else. They're just mechanical objects that operate on a really small scale with high precision. And
Yeah, well, to your point, as like the whole object of their philosophy, like with quantum physics and stuff, is to move reality into a set of numbers where then you could just kind of make up stuff and there's no real foundation to your reality because the whole thing is sort of abstract. And I think that's kind of their way to push like nihilism in terms of this like, scientific model, which, we all know is at its heart is just like without a creator, without any kind of, purpose to it.
right, and it's because so this is going to kind of get into the philosophy of science a little bit, but it's important. They treat laws of nature as if they're real. And what do I mean by that? Like, there's no such thing as laws of nature. Like, Newton's laws don't exist. What we see as Newton's laws, like F equals ma, it's not a real thing. It's a relationship between entities. Entities are just, physical things that exist, right? Independent objects or things. The things themselves serve as the basis of reality, and the relationships between those objects and how they interact are what we measure, and we can see consistent patterns in the way that these entities relate with and interact with one another. And those are what we describe as laws. But don't make the mistake of assuming that laws are somehow primary, as if laws could exist without entities, because that's absurd. The laws don't exist on their own. They're just describing the entities' interactions. So then if you take away the entities, you don't have anything left. You can't have a law of entity interaction without an entity to enforce it. In this way, we see the folly of modern science, because they point to us to these ideas that tell us, yes, you can know, you can measure these things and their values, but the values are just representing the confirmation of the laws. They're not measuring anything that's physically real. When you measure electromagnetic forces in space, you're not measuring anything that's physically real. There's nothing there. It's just a vacuum, and there's fields, which are not fields, by the way, are not physical objects. Just so you know, they're math equations. They're vector number spaces, regions of space where forces are measured. They're not physical things. And so they say we're just measuring forces in space. Well, okay, what is imposing those forces? Well, the fields are imposing the forces. Well, I thought you just said that a field is just a definition of a place in space where we measure something. Yeah. Okay, so then how is the field imposing a force. That's like saying that the measurements are causing the measurements. It doesn't make any physical sense. When you take away the ether, when you take away the medium, the entity